Good day. Again, this is a recap of notes that you saw last year. And Lewis Structure's Tendencies, I think it's a really important one because it means when you finish off a molecule or complex ion, you have a pretty good idea if you did it right, if it fits with these tendencies. So friendly reminder, group 4, you're going to end up with 8 electrons around them, all involved in bonds, so there are no lone pairs. If it's group 5, like nitrogen, phosphorus, you end up with 3 bonds, and that means you have 1 lone pair left over to get up to your 8 electrons. Now, group 6, we're talking about oxygen and sulfur, selenium, tellurium. And you can see as the number of bonds goes down, the number of lone pairs goes up. Group 7, it's the 1 and the 3, so unless they're in the center of a molecule, which is possible, but fluorine, chlorine, bromine, iodine, they will tend to just have 1 bond. They tend to be on the outside. But if they're in the center, then things can be a little different. And you do have to remember for hydrogen, it's very small. It just needs 1 bond. So hydrogen's always going to be on the outside of a molecule or complex ion, and it will not have lone pairs. The big mistake people make is for some reason they top it up to a total of 8 dots, 8 electrons. So that's a no-no. So elements that want more bonds will be in the middle of the molecule or complex ion. So if you see carbon or silicon, it's going to be in the middle. If you see nitrogen, often it will be in the middle. So as we said, hydrogen's always on the outside, 1 bond. And when you're trying to set up the structure, another tendency is that they will end up being symmetrical. And it's too bad that word symmetrical isn't actually symmetrical. Another fault of the English language. Now notice these things are called tendencies. It would be nice if they were all the time things, but tendencies means most of the time this is what we run into. So hopefully you remember this stuff. If you don't, that's why we went through it again.